Okay, so the graph below shows flow of a wastewater in litres per minute through the system of pipes connected from the source to the sink. Okay, so source to the sink. The maximum flow possible in litres from this. So this is the one where you can do cut method, which I don't like because I can never find the actual cut anyway. Or you can do it the flow way. So the way we looked at it is we first take through all the paths. So if you look at it, I've got 11 flowing through here. So that means only 11 can get through there because we're bringing in 11. And then when you get to here, well, only 10 can go in because that pipe only takes 10. So what you do is I like to say, all right, we've used 10 out of 10. So 10 came through here and 10 came through that 11 pipe. So I sort of gone backwards. So no more, because this leads into the 10 one, you can't use it anymore. And the same with this. So I'll just cross it, no more looking at that one anymore. So then I'm going to look at my next way to get into from source to sink. So if I look here and I go, all right, 9 can come through here, but I get to there, this pipe can only take 7. So I'm going to say, all right, I use 7 out of the 7 there. And I've used 7 out of the 9 there. But if I look at it, and now if I go to the next bit, if I have a look at this 8, this 8's going to go into here. So it's already full. So I'm going to get rid of that 8. It's not doing anything anymore. Can't be used. And there's no more coming through here because it's going into that 7. The 7, this pipe is full. This pipe is full, no more can get into it and no more can get into that either. So then I go along, if I go along the bottom here, I've got 10 coming in and I get to here. Now, all 10 can go into there, can't it? But that's all it's got to offer. So only 10 is coming in and we've used up all of that. So you look at the ones going into the sink. So the sink ones are those pipes. So I've used all of the 10 here, plus all the 7 came in, but only 10 of that even though that pipe could take 15, only 10 could come through. So what's the maximum flow? Is 27. Now, if you go through, you would find a cut that adds up to 27. I don't like doing it that way. Okay, so the network below shows the distance in metres between garden lights that are being installed and the vertices A to J are the garden lights. The minimum length of cable required to connect all the garden lights. So you just got to think, if you had a live wire and you just need to get that live wire from one to all of them, what that means is this is a minimum spanning tree. So just so you're aware, so a minimum spanning tree, and if you remember what we said with that, you pick your starting vertices. So I'm just going to, it doesn't matter where you start, I'm going to start at A, and I picked the smallest one out of it, okay, so and then I'm B. Now looking at A and B, the smallest thing coming out of A and B is a 4. Now there's 2 4s, but I'll just pick one of them, it doesn't matter. And now looking at A, B and C, the smallest one coming out where I'm not going to loop around. So therefore I've got that 4 now. Now looking at all of them, what's the smallest one coming out where I don't loop? It would be up the top here, yeah? Because if I chose the other 6, it'll loop. If I chose the 5, it'll loop. I could choose that bottom one, but I just go on the top at the moment. All right, now if I look at all my ones highlighted, so 4 is the smallest. If I'm looking at all these ones highlighted, 3 is the smallest. If I'm looking at all of them now, I've got this 4 is my smallest. Looking at all of them now, this 4 is my smallest. Now, I've got to make sure I've got all the dots highlighted. So I've just got J missing, but you can see the smallest would be out here. So then what you do is you add up all those numbers on the highlighted edges, and when you do that, you end up with 38. All right, let's go. The network below shows the sequence of activities A to H. required to complete a project, the duration of each activity in days is shown. The project is to be completed in the minimum time possible. What's the latest starting activity time for B in days so that the project is completed in the minimum? So you probably just want to do, and this is near the end of the exam. The exam was on 40 questions, so you're going to be having to do a bit of work. You're probably best to do the critical path method where we do it like this, yeah? So we start off, A is 0. When you get up to here, I've got two options where I can go. I can go C and D. So it took me 3 days to get to them, so I'll pop it there. If I want to go down here, start E. E had to wait for B, so that was 4 days. Then we get, I'm just going to keep going. Over along here, I've got F. Now, I would have gone 3 plus 5, so that's 8. And if I go down here to G, now I have to be careful because there's a couple of ways. I could come the E way, so 4 plus 6 would be, I'm just going to pop it there, is 10. I could come the not via D, so it could be 3 plus 9, that would be 12. So remember, we take the bigger one, so I've put 12 there because via D was 12. And then I'm going to wait, that's why I waited, because I wanted to see for H. Now H, I can go 8 plus 7, that would be 15, or I can go 12 plus 4, which is 16. So that's the bigger one. That's why I picked it. And then you go to the end, 16 plus 5 equals 21. So that's the finish. So now when we backtrack, so we start at back and we go backwards. So 21 minus 5 is 16. Now, if I'm going backwards via G, 16 minus 4 is 12. Now, if I'm back at H and I go 16 minus 7, what's 16 minus 7 is? 9. That's why I get a little bit of difference there. All right, now, to go back to D, I'm going from this 12. What's 12 minus 9? 3. Good. And then if I go back, I'm up here at F, and I'm 9 minus 5, going back via the C way. What's 9 minus 5 is? 4. That's why I'm putting 4 up there. Now, when we're here at the CD spot, when you're going backwards via A, you have to pick the smaller one. So you pick 3. And 3 minus 3 is 0. And now I've got to do the bottom bit. If I go from here, G, 12 minus 6, that would be 6. And then 6 minus 4 is 2. So the critical path is the ones where their numbers are the same. So if you look here, we go along there up to D. D's the one with the same number. Then G, then H. So there's the critical path, and you've got all the float times are there. So if it said, what is the latest starting time? So for us, the latest starting time is in the red for activity B. What was it? 2. Yeah? Can you see there? Yeah. So latest starting time is, there. So it's 2.
Yeah, you have to do the whole thing.
Okay, the table below shows 7 activities A to G required to complete the immediate predecessors of each activity is shown. In the directed network presenting, the project will require a dummy activity. The dummy activity will be drawn in at the end of. So hopefully you can see here, remember when I said, when you see a double up here, you know there's the dummy activity is going to be somewhere in here. So when there's one with an, when you see one letter by itself and then also in another set, there's going to be a dummy. So it's probably best, and we might as well, we'll just practice drawing up this activity. So I'm going to practice drawing it here. So I've got activity at A and B. They don't have anything before them, so out they go. if I look at C, C comes from A. So C, okay, and D comes from B, okay. That one's pretty easy. D. Now, when you get that, you know there's a dummy activity here. You got C and E has C and D, and F has D. What I suggest is go to the one that only has D coming out of it, and that's one I like to do next. So I'll go, all right, there's F, yeah? So I know I've done that one. Then I go back to the other one. E said it came out of C and D. So I'll put it coming out of C, but it has to have D happen before it. So that means here's where you're putting the dummy, yeah? So the dummy, D has to be finished before E can start. And so there you go on. And then G, if I finish that, G has E and F. So, sorry, these two would group in and you'd have, G, okay? So now I've got a visual. Where does the dummy act it? It will be drawn from the end of, where did I draw it? At the end of D and to the start of E, yeah? Because you can see the arrow going. Okay, the directed graph below shows a sequence of 12 activities required to complete a building project. The time to complete each activity in 12 weeks is also shown. The owner of the building wants the project to be completed in no more than 16 weeks. The durations of activities D, E, G, J, K, and L can each be reduced by 1 week at a cost of $1,000 per activity. The least cost to reduce the completion time of the project to 16 weeks is. So what you have to do is you originally have to go and find all the paths. You have to find the original critical path and the time, and then you're going to do the crashing activities, or then look at what activities you can crash. So and they've told me that, so I'm just going to write D, E, G, J, K, and L. But first of all, you've got to write all the options of paths. So my first path I'm going to go is across A, D, H, and K. So I just like to start at the start and I go across the very top. There's my first path. If you add all them up, it's 13. The next one that I could do is I like to go across the top, and the next one would be A, D, and then I'm going to go I, J, K. All right, so I've got to go through every option, and there actually is quite a few in this one. But it'll just make, if you just don't hesitate, write them all out, it'll go quicker. So the next one I'm going to do is A, D, I, and then I'm just going to go straight up to use L. And that one was 17. And now I've done all of them. I'm going to move to the B, where I went along B, E, H, and K. And that one was 12. And then I'm going to go B, E, I, J, K. And that one was 17. And then I've got B, E, I, and L. And that one was 15. Then I've got B. I'm going to go F now. F, J, and K. B, F, J, and K, which is 16. Then I'm going to go B, F, and L, which is 15. And then I'm going to go what am I going to do? C, G, J, and K, which is 19. And then I'm going to go C, G, L, which is 18. So there was a fair few, but it's okay. All right. So if you look at what's the critical path at this time, which would be what? The largest one? Yeah? What is it? This one? So 19's the largest. So originally, this is his critical path. So remember the largest one, so it'd be J, was it? J and K. That's the critical path. So the largest one has to be done. But now he wants it to go to 16. So we want to crash, and we want to crash any of these activities here. And we want to go, we want it to be 16 weeks. So what I suggest you do is you can crash all those activities by one day. So let's go and highlight them in our, so highlight them in your paths. So this one has D and K, which can be changed. This one has D, J, and K, which can change. So I'm just circling all the letters that can be altered by one day. E and L, J and K, L, G, J, K, and G, L. And then I'm going to put in their new times. If I did that, this would reduce this one to 12. This would reduce this one to 15. This one would reduce that one to 15. It would reduce this one to 10. This one to 14. This one to... Wait a minute. What am I up to? 15, 13? Yeah? Yep. 16 to 14, 15 to 14, 19 would go to 16, and G and L would go to 16. So here you can see here's your new critical path. All right. So to get the biggest one down to 16, I would have to crash all three of them. Yeah? And so if you look at this one too, we would also have to get this one. So to crash this one, to get to 16, I need to crash G here. I've picked G, J, and K. But this one also has to go down to 16. And you can see it has G, but there's also L. So I need to use L. All the rest are... If you look at this one is already 16, but it's dropped to 14, so it doesn't matter. You don't have to crash anything in it anyway, but it's getting crashed. K's getting crashed anyway. If you look at 17, it would only need one, and K is getting crashed anyway. Yeah, so that one's gone. And so therefore, you only need to crash these 4 activities, and you crash them by once, and if it's by 1,000 each, then 4,000 is the limit. That's the last question of the exam. It was meant to take time. So this is now exam questions. So the map below shows 7 countries within Central America. The network diagram was drawn with 7 vertices to represent the countries. Edges are drawn to represent the borders between the 2 countries. The number of edges in the network is... So it's probably handy if you do have a highlighter, because you just had to do the borders. So there's 1 border, 2 border, 3 border, 4, 5, 6, and 7. I just counted 7. Yeah? So if it's a border between a country, you just have to count it. So an athletics club needs to select one team of 4 athletes. The team is required to have 1 long jump, 1 high jump, 1 shot put, 1 javelin. The following table shows the best distances in metres. And there they are. The athletes club will allocate each athlete to one event in order to maximise. So this is where you've got to be careful. When we're maximising, we don't do the Hungarian algorithm. Because the Hungarian algorithm we show you, that is to find the minimum time, the minimum cost. This is a different scenario where we want to allocate, but we want the largest. So what you want to do, just do the inspection method, and I'll help you with that. So I saw the similar question this year in the 23 one. So it said maximise, and they actually put maximise in bold for them. So obviously big troubles. So what you want to do is when you're just doing inspection, remember we said you should highlight the biggest. So because you want the biggest throw in, say the biggest throw, biggest jump, the biggest high jump, and so that. So I go down and I circled the biggest value, okay? And then the biggest high jump, biggest shot put. And then in the end, I saw that the biggest was the same athlete, yeah? So biggest, the same athlete. So that's not going to help me. So then what I did is like, all right, I'm just going to go and I'm going to find the second biggest. And I'm going to use a square for it, all right? So if I go through the second biggest, here's this, and they all three did the same there. This one, the second biggest was 1.7, so there was 2 there. Here, the second biggest was 13.9, and here, 40.9. So then what I did was I worked out, because I went, all right, the best athlete can't do everything. But what I want to do is I want to lose the least amount of distance between whichever one. So whoever gets closest to being the next best, I'll take that for the job. So what I'm saying is the difference between first and second, like, you know, in here. So if I look at this would be, so for this one, it'd be 5.1 minus 4.8. So I get 0.3. So the Shona throws 0.3 more. If I look at the difference here, it's only 0.1. If I look here, it's 0.5. And the next one is 0.3. So if I don't want to lose whatever there, I want to lose the least amount. So which one? I want Shona to do shot put. Does that make sense? Because if I didn't, I'm going to miss out on 0.5. Yeah? So that's the bigger one. So now, because this is the biggest, I say, all right, I know Shona needs to do shot put. Now, if you go down to your answers, if I minimize that, look for Shona in shot put. How many is there where they put Shona in the shot put? I think there's only one, and that's D. So I'm done. This one's pretty bad. It says, consider the graph, the number of edges that need to be removed to make it planar. So remember, you can't have it crossing. So first of all, see this one here floating in there? It crosses so many. Now, you can move them. So if I moved that out here, so that blue one, I move out there. Now, obviously, I can do this on my laptop. I'm going to see, I erase that. So I essentially haven't removed it. I just moved it. And you can move them. And then if you look at it, I've got another one crossing. So say this one. But I could move it on the outside there. Yeah? So if I move it, it still connects. And if I move that one, then I would delete this. Now, how many have I got crossing? I don't have any crossing now, do I? And I didn't remove any edges. So how many edges need to be removed? 0. Okay, a connected graph consists of 5 vertices and 4 edges. Which of the following statements is not true? So when you're connected, it just means that there's no floating ones, no isolated ones, okay? So if you have a look at it, which of the following statements is not true? The graph could be a tree. Of course, it can be a tree. So if I do 5 vertices, 1, 2, 3, 4, 5, there you go. I can join them up in 4 edges. That's a tree. There's no loops. The graph could be planar. So just test that. If I even just test this, what I drew there, I have, if you go F minus E plus V equals 2. In this scenario, I've got 1 face, I've got 4 edges, plus 5 faces. Does that equal 2? Yeah, it does. So it can be planar, so that's a lie. The graph can be bipartite. Bipartite just means you have, like, your vertices like this, and you have edges. And it doesn't matter. So 1, 2, 3, and I could have 4. It could be bipartite. It doesn't matter. So that one, it can be that. The graph contains a path. Yes, that's okay. And the graph can contain a cycle. Now, if you try to, remember, it's got to be connected. So if I draw a cycle, okay, so I've got 1, 2, 3, 4, and then if I have another edge, another vertice, 5, but I've already used 4 edges, I can't do that. And so you'll see you can't get a cycle because it you just can't float right back. You don't have enough edges. So this one is incorrect. The graph can contain a cycle. It can't contain a cycle. Every time I draw a cycle, I run out of edges and I end up with an isolated edge. With this one, so in your reading time, you need to have a look at what's happening with these questions in networks. Am I going to have to do a whole critical path? Am I going to have to, and so on. So here, I've read it. It says here's like a directed network, and it said the earliest starting time for G. So because it doesn't continue on with any other questions, I pretty much just need to get up to G in my critical path. So if I have a look, I'm just going to start it like I normally do. And I do need to be careful because I can see that there's a dummy activity leading that way. So I better check around here. And the dummy activity comes from E, so I better check for that way as well. So let's have a look. So A and C have nothing before it. If I follow along A, so D can't start till A is finished, so that's C. Now, if I go along D to G, that would be 6 plus 5. I'm going to just write 11 on the top because I know I can see there's another way in, so I'm going to check that. I forgot to put B here. B starts on 0. Now, if you get to here, B would be, you would have made it by 10, yeah? So H, if you're going to go along, so 10. But you can see that has to happen. So B would be a 10. So at the moment, 11 would be the earliest. And then if I go along via E, E would be 5. What's 5 plus 7? That would make 12. So you can see 12 is actually the earliest starting time. So you could just stop there if you like. You don't need to go all the way through and backtrack because there's no other questions on it. So we'll just stop there. Okay, so it says we need to take note. This one is 7 and 8, so we're probably going to have to spend a bit more time. And if we've got to draw things out, probably we are drawing the whole thing. Okay, so we've got 11 activities. They've told me the earliest starting time and the duration, and they've told me the immediate predecessors. So it said a directed network for this project will require a dummy activity. The dummy activity will be drawn at the end of. So I've got to find the dummy activity. If you look ahead, question 8 asks for the sum of all the float times. So we have no choice. We're probably best to draw a whole activity and do the critical flow through it. So I'm going to draw that with you. So let's start that off. So we've got A and B. And they give me how long A goes for, so I can put those little numbers on it. And I've got B, which is 7. We then go on to C comes out of A and D. So I can see, I'm going to put C come out, okay? So we've got C, and I've got to put its duration, which is 10. And it also has D, which was 7. Okay, done that one. E comes out of B, and it has a duration of 8. Now, F comes out of D and E. So because I can see here, this is where I know there's going to be a dummy here. So when we see a dummy, I say go and draw the one that is by itself first. So I know G comes out of E. So I'll draw that one. So G comes out, and G has a duration of 2. But then I go back to F. Now F came out of D and E. So I'll put F. I can put F coming out of D for 2. But it also has to have E. So there I can see, all right, I've got to put a dummy in there. Okay. So I could stop here now. And it says, you know, where's the dummy activity drawn from the end of E to the start of F. So there's B is your answer. But I know I have to have the whole diagram for question 8, so I might as well keep going. So the next one, I'm up to H comes out of G. So H comes out of G, and that's 3. Now I has C, F, and H. So I'm gonna redraw H up here. So H, which had a 3, and now I have I coming out of those ones, and I is 6. And then J comes out of G. So that's J with 5. And then K comes out of I and J. So join these up. And I've got K, which is 2. And we get to the end. All right, so if you look at, I'm going to take this onto my next piece of paper. Okay, so with the next question, it says when the project is completed in the minimum time, the sum of all the float times in days will be. So remember, the critical path have 0 float times, but all the rest will have a float time. So I've got no choice but to do that critical charting the way through. So I'm going to start here. I've got A and I've got B. They're 0 and 0. When I get to this point, I have either C or D. Now, they both had to wait for A to happen. If I look here, E had to wait for B, so there's 7. Now, I get here G, so 7 plus 8 is 15. And if I go along here to F, F would be 6 plus 7, which is 13. But we've got this 15 from there. Has to wait for G, so 15 goes in there. If I look at, if I look at I, if I go along the C path, it would be 16. If I go along the F path, it would be 17. So this is along C, this is along F, and well, I could go along H, so I need to work that out. So H and J, 15 plus 2 is 17. Okay, so if I went along the H path, 17 plus 3 would be 20. So I've got to take the biggest one, 20. And then if I get to K here, it could either be 17 plus 5, which is 22, or 20 plus 6, which is 26. And then we add the 2 more on, and we get to 28, the finish. And then we've got to go backwards. So we go 28 minus 2, 26. 26 minus 5 along the J way would be 21. 26 minus 6 would be 20. I get to there. Then 20 minus 3 along H would be 17. Or 20 minus 10 along the C way would be 10. And then 20 minus 2 would be 18 there. And then I've got to do that. 17 minus down here on G, 17 minus 2 is 15. 15 minus 8 is 7. 7 minus is 0. So I've gone back that way. 18 minus 7 would be... No, what is that? 18 minus 7, what would that be? 9. Wait a minute. So 18 minus 7 is 11 there. And then 10, you've got to pick the smallest. So 10. 10 minus 6 is 4. So they're asking you to the sum of all the float times. So they're going to be, if I look at them, you've got to just add them up. This one's 4. This one's 5. Oh, sorry, I'll do it in a different colour. This one's 4, 5, 4, 3. Down here we've got a 4. So there's all those float times. So if you add them up, you got 4 plus 4 plus 5 plus 5 plus 3 plus 4, and that equals 20. Okay, Joe plans to add new cabins to a holiday park. The project runs 10 activities completed. How many of these activities have 2 predecessors? So if I'm looking for that, I can see an activity that has 2 lines coming into it. So there's one. Here's one that has 2, and here's one. So this one would just be 3. There's 3 activities that have it going into. And it says it is possible to reduce the completion time of 2 activities. One activity can have its completion time decreased by 2 weeks, and another activity can have its completion time decreased by 1. These 2 changes result in the completion time being reduced by 3 weeks. So we're going to change our minimum by 3 and complete the table to show that the activities. So hopefully you've read in reading time and you know this is a crashing. I'm going to write out all the paths and work it out that way. So off I go. I'm going to do that over here in blue. So I'm going to put all the paths that I can do. Whoops. All the paths I can do and their times. So the first one I'm going to say A, B, E, G and J, and that one would be 26. Then I'm going to do A, C, F, H and J. Add that one up, it's 29. If I do A, C, F and I, go along the bottom there, that one's 30. If I do A, D, H and J, that's 29, and A, D, I is 30. So this was the time. So the original minimum completion time is 30. So 2 changes result in the 30 being reduced by 3 weeks. So new minimum completion time is now 27. Okay, so that means I have to get these numbers down to 27. Okay, this one I don't have to worry about. So if you look, this one has to lose 2. This one has to go down by 3. This one has to go down by 2, and this one goes down by 3. So look at the letters that they all have in common. So you can, the ones that you've got to change. So they all have A in there. So I'm going to pick that one. And then if you look at, so these 2, oh sorry, they can all have A, 2 taken out by A. So I'm going to say A by 2. Now I need these ones to go down by 1 more. So I've already taken 2 out. So if I take one and I look at what's letters in both of them and not the other, and it's I. So I can take both out. So I've got I, and I only need to take 1 more, out, so I can pick that one. Alright, up here it's asking me, if you read it all, I'm not going to read it all, but it says determine the capacity of cut 1, so that's this cut here. So remember, anything going from source to sink, so we'd count 19, we'd count 11, we'd count 14, we'd count 15, and we'd count this 15. Not that 5, because it's not going from source to sink. So if you add all those up, 19 plus 11 plus 14 plus 15 plus 15, you end up with 74 is that cut. And what is the maximum flow per meters from source to sink? So with the flow, I don't like to use the cut method. I'm going to use the other way, the flow through. So let's go through that one. So if you look, I'm starting off here, I've got 20 coming through, but only 18 can push through here, and only 15. So in the end, I'm blocked, only 15 can come through here. Okay, so I've used 15 of it. Anything leading into that last one, this one, nothing more can go. So anything that just leads into that is crossed out now. So I can't use that one. I'm not going to use this 5 because it's only leading into my full pipe, and then off we go. I shouldn't cross that one out because it can come back down. So there we go. So now I'm going to look at other ways to get the flow into there. So then if I look at, all right, I had 15, I've still got here, I could push another 3 through here. If you look, that would make this one 18, and I've got 3 coming in here. All right, so I do that, and then you could say, all right, so 3's coming in. Let's try and get that 3 to the end. So 3, I can push it along here, 3 and 3, and into there. So there's 3 gone through. Then we can go, let's try and push some of this. We're taking 35 out of here. So if I look, I've still got another 13 to come through. Oh, let's push through 7 to come through this way. So I'm going to add 7 in here. So this pipe's full now. I could have added 7 to that. I could add 7 to that, and I've taken 7 out of that. And then we've got to keep going. So now this one has no more that can get into it, so it's stuck now because that one, we've filled that tank up. So that one's stuck. And all 10 went through, so we're not going to use this one either. And yeah, we're crossing this one out. So now we've got 10. We've still got, and this one can't go anywhere either, so these guys are out. So they're all out. So now, if you look at it, I've got 35. I can push 20 through there because I've still got 20 left here. And I still got 19 to go through there. So I'm going to push 19 through here, 19 and that. So if you look at the last ones, we've got 19 here, 10 here, and 15 here. So maximum flow, 15 plus 10 plus 19 equals 44. Okay, Joe would like to increase the maximum flow through the network. The maximum flow through the network may be increased by reversing the direction of flow through one pipe or increasing the capacity. The direction of flow is reversed through one pipe. Complete the following sentence by filling in the boxes. The pipe that should have its flow reversed is to cause the largest increase in flow from source to sink. The pipe that runs from, so we want to reverse a pipe which will allow more flow in. So if you look at the ones that are reversing, if you look, we've got, and then what pipes still have stuff room in it. So if you look here, this pipe has room, it's only using 10 of it. And if you look, over another one. So if I reversed maybe this one, and if you see what else we've got like owing, so if you think we've got +6 here, over up here we've only used 29 of it, so we actually have +6 available to come out through here. So we do have enough to come. So if we push that 6 along, and it could go either way, we could then push it through this pipe if it was reversed. So we're going to reverse the pipe that runs from Q to P, we'll reverse that one. Okay, the capacity, then in the next question, we've got the capacity of the one pipe is to be increased. So we're not thinking about what we just did. This is a different scenario. So if I, I'll just take the little arrows off. So we'll leave that there. But if you think about it, we know we had 6 available here, and so we're going to increase a pipe. Well, this pipe is already it's already big enough, but it just can't take it can't flow in. So if I increased maybe here or whatever, the flow going in, all I could do is increase, all that could come in from there is probably over here, the 6. But what about if you look at what else we've got extra, this one still has 3 allowed to come through, and this one has 4 still coming through, and we've still got the extra 6 to come through too. So if you think about it, we could, if we increase maybe this pipe here along here, we could push this extra 3 in. Now we've also we've got 6 here available. Now this 6 could go along, so we've got 6, there's still room for it to come through here, and there's still room for it to come through here, and then we could push, and so we've got 6 extra, which ends up, well, at this point here we can only put 5 through, but then we could push 5 here, so then we'd have an extra 5 coming in. So if we add to this one, add an extra 8 litres to make it a pipe of 23, it'll increase it by that. So increasing this pipe increases it by 8. If I only increased say the pipe, if I increased say this one, it would only allow 5 to go through, so it's not as much as 8. So the increase, if we want to increase one of the pipes, it's going to be the one between L and R, and we'll increase it to 23.